welcome back to the greenhouse, and if you're new here, welcome. Today is day 4 of our compost heater, and it is fully active now. I just shut our air moving system off because it's pretty loud and hard to hear me. Our water system needs a little attention and tweaking, so that's what we're going to be covering today, is getting our flow rate down to the correct flow where we can produce a lot of heat. So we're not overflowing the system and we're getting a good heat transfer from the pile into the greenhouse. Now this can be very tedious and this can be kind of repetitive. So I apologize in advance if it's all kind of similar, which it is. But for this data collection, the refining of these systems and the fine-tuning of the system, I wanted to share every little step along the way, from the very first parts we put together for the build all the way down to the very last parts that we use to complete this heating system. If that sounds interesting to you, please consider subscribing to the channel. This is pretty much all we do here, so let's jump right into this. So lowering the flow rate on a pump or on a system, there's quite a few ways to go about achieving this. The first is swapping pumps. So we've already went from our 1100 gallon per hour, or about 18.5 gallons per minute pump, put that in our pond. Swapped our pond pump in here, which is 350 gallons per hour, or about 5.8 gallons per minute, which is still a little high for what we want to achieve here. Heard a gunshot that sounded kind of close. There ain't nobody around us, so it must have been the survey crew over there checking out the main road or something, firing shotgun shells possibly for a sonogram? I don't know. Don't quote me, I'm not a geoengineer or a survey crew. Back to what we were talking about here. So we went from the large pump to a smaller pump at 5.8 gallons per minute. Now, I have this extra pump that we're going to be using for a heating system. Now, I can get another one of these or use a different pump for our heating system. I'm going to steal this and swap this 280 gallon per hour pump. We can check it out here. Just this simple little pump. I showed this, we ordered this specifically to move heat to the stove and from the stove to a thermal mass, but that is for a later video, so we can use it for now to test our system. So swapping pumps is a great way, and this 280 gallon per hour equals about 4.6 repeating gallons per minute. So we've lowered the flow rate a whole nother gallon per minute or so. So we're going to see if we can't get some good results with this, even though it's still a little bit much. It's maybe a 1/4 inch output as opposed to our 3/4 inch or 1/2 inch outputs on the other pumps. So I just want to test this out and see what it does. So moving on from swapping pumps, we can also, now I just made myself a DIY gasket out of some electrical tape here. So we're going from the 5/8 to 1/2. Very significant size difference on the actual flow there. So that's another method, is by restricting flow. And when you're dealing with water pumps, it's not the same as a fan. A little bit of back pressure is not going to hurt the water pump. The more water that is available and the more pressure that it has, the less it has to work to push it. Even though you may lose a little bit of efficiency on your pump itself, you're gaining the efficiency with this system, specifically compost heating. So just taking a recycled piece of PEX and popping this little fitting in here, we can decrease the flow rate at the end of the pump also, where it dumps back into our tank. So a few more methods we could use to decrease flow on a water pump is changing your impeller size or trimming your impellers, which I'm not going to do either of those. It's something I could do, but it's not something I want to do. I would rather achieve it through other means, by swapping pumps, smaller pump, or restricting flow. So we're going to go ahead and take our old pump off here. Oh. So this is a completely DIY gasket here. Now I'm going to take some electrical tape, wrap it around this little barb here at the end. We're going to create ourselves like an 1/8 of an inch barrier on the outside to allow it to fit into the PEX here. So simply removing our old piece of PEX here from the pump that is on. So in the true sense of DIY, let's see how well this little DIY gasket fits. Ooh. Alright, well, it works. Use a hose clamp to snug that up a bit. Drop another hose clamp up on the top here. Drop our pump in, attach it to our system. We're going to tighten down the hose clamp. So we've got our new pump attached to the system. All I have to do is plug it in, and we will see what kind of flow rate we're getting and what kind of temps we can pull. Alright guys, so we are on the backup camera, so I apologize for a poorer quality. This camera decided to go kaput. The battery is toast on it, so we're out here filming with the backup camera. We're gonna pull some temps from this system we had just set up. About 63 on the floor of the greenhouse. All that water was sitting in there. We're gonna get a huge increase. Still seems to be flowing quite a bit of water here. I went ahead and I put our little downsizer in here. It definitely increased the pressure, which reduced flow, even though we still need less. We're probably flowing about maybe 2 gallons per minute, or a little bit better than 2 gallons per minute. So we ended up still sitting right around the 90 to 95 degree mark. In between those, it's a little bit up, a little bit down. We can go ahead and click on our space heater here. Man, instantaneous dry hands, instantaneous heat. Very nice. We showed the temperatures from this yesterday. We're pushing like 115, 114 degrees. Compost pile, smelling like an active compost pile, just steady, sitting on 150 degrees. We're back out here with a fresh battery here. Now, we did not achieve the exact flow rate we wanted. We were a little bit high, maybe 2 to 4 gallons per minute. The pump's rated at 5.5. So we did decrease the flow with our little restrictor going from, what, 3/4 down to 1/2 inch. We're using the smallest pump we've got. So by swapping and exchanging pumps, using anything we have on hand, we've had to purchase a few things, and we've spent just under $20. Now this is a little inline ball valve. Now if anybody knows what a flow restrictor is, it's a funky looking piece that connects inline on your pipe, and it's usually got a little gauge on it. I'm going to try and find a picture and post one up here. But that is controlled by screwing a spring and holding the pressure to allow a certain amount of flow. Now, I can do the same thing with this ball valve, and this was my last resort. I didn't want to have to resort to restricting the flow very much. And without buying a new pump, this is pretty much what I've got to do. So we're going to jump right into attaching this little ball valve to our system and see what kind of flow rate we get. It is getting pretty dark out here now. It's like 5:15 and the sun is pretty well gone. It was cloudy all day anyway. So hopefully we've got enough energy stored from the sun to be able to operate this system long enough to check the data and see what kind of flow we're still getting. So this little ball valve has 2 barbed ends, which we will be able to just plug right into our PEX tubing here. So we're going to be taking out this little attachment we made, little flow regulator, downsizer, DIY flow regulation here. So we're going to out with that and in with our little ball valve here. So just checking the ball valve here. You can see it starts to close off and it's completely closed there. Open back up. It's getting so dark that our lights just kicked on here. We've got all of our tunnel lights in the greenhouse here. So we got the ball valve, we've got a little hose clamp. Slide the hose clamp on here, attach our ball valve to the end, and we're going to secure it in here. A little chilly, I had that door open. There's nothing like a compost heated space heater here blowing like 100 degrees on my cold hands. I'm going to kick that heater back off so we can hear what's going on here. Now, we're going to go with a 1/4 turn and see what kind of flow we're getting out of there. Maybe a little more. Make our final connection here. The pump is on. got a decently strong flow rate. Looks like I got a little bit of leakage here. I can tighten that up still. So we're gonna go ahead and we're gonna take some temperatures. So a lot slower flow rate, takes a lot longer to get that heat up to the point where it's coming back out. Okay, so we weren't really picking it up there. 84, 85, 86, 87, 88, 99, 101. It's getting pretty hot on my hand there. 108, 110, 113, 116. Oh shoot, it's getting hot. So now that we've achieved the proper flow rating, I mean, that is probably about a little over a gallon a minute. I'm gonna do a test and I'll fill up a gallon jug, obviously, and time it, and we'll see where we're at tomorrow when the sun comes out, because we're out here working under our lights in the greenhouse here. It's getting pretty darn chilly outside, so being able to just click the space heater on, usually I just run it. It runs on a timer, so about every half hour it's gonna operate, unless I just completely bypass the system and run it 24/7. But I like to have these solar systems on timers to be able to get better longevity out of the energy that we do have. So we were holding about 115, 114 degrees out of the water. It spiked up to almost 125, 130 or something, and it was getting really hot on my hand, and I was just trying to hold out so we could see some real temperatures, and I want to be able to hold 120 plus flowing through there at the correct rate, because that is what it's all about, is having the proper flow to be able to achieve the type of heat that we're talking about, to be able to pull all of that energy without overdrawing the energy off the system. So this was day 4. We're pretty well fine-tuned on our water system. We're gonna do a little bit more tomorrow, day 5 or day 6, with these systems, and get a little bit more data collection, and then we're pretty well home free. This can just run autonomously by itself. This has been a super interesting subject to me. I've been fascinated with this and many other things over the years, and this kind of just stuck with me. So I like to share all of the data and all of the operations that we're doing, all the little experiments, tests, and tweaks. And like I said, I spent maybe $20 on little attachments and fittings to get the PEX together, and then I spent $12 on that ball valve. So it was relatively cheap to achieve the flow we wanted. We are using the smallest flow pump that we have on hand, and we could order another pump, but if I can just get by with this system for this winter until next winter when we redesign this whole system again with more permanent metal parts as opposed to all of the PEX and stuff like that, I think we could get a lot better heat transfer. That 55-gallon drum is definitely holding 150 plus on thermal mass, and that really aids in the transfer as all of these water lines are wrapped around that barrel in the pile. So if you've got any questions here, definitely drop them in the comments below. I appreciate everybody sticking around, watching all these videos, and just having general interest in this subject and other things that we share. So I'd like to thank you guys. Thanks to all my subscribers. This channel is what it is because of you guys, and I will see you guys tomorrow in the next video.